In the previous lesson, we studied Euclid's first 4 postulates. Take a moment and go through them. So now let's move ahead to the 5th and the last postulate from Book 1 of Euclid's Elements. Let me tell you that it sounds complicated but isn't really that complicated. The 5th postulate says that if a straight line falling on 2 straight lines makes the interior angles on the same side of it taken together less than 2 right angles, then the 2 straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than 2 right angles. This postulate clearly sounds a bit complex as compared to the other 4 postulates. But we will break it down line by line to grab a good understanding. To break it down, let's rephrase this postulate. Suppose we have 2 lines like this and a third line falls on them. This third line divides the system into 2 sides. One is this part where the 2 lines are bending towards each other, and the other is this part where the 2 lines are bending away from each other. Then if we extend the lines, we see that they will meet at some point on one of the sides. We see that they meet on this side. Then these will be the interior angles made by the third line by falling on our initial lines. And the sum of both these angles will be less than the sum of 2 right angles. In simpler words, the sum of these angles would be less than 180 degrees. Note that Euclid did not use 180 degrees to compare the angles. Instead, he compared them with the measure of how many right angles. This is because in postulate 4, he stated that all right angles are equal. So, this gives him the right to use right angles as a unit to measure and compare other angles. Could there be any other way to understand this postulate for more clarity? We have seen the Euclid's 5th postulate, and clearly it's a bit complex to understand compared to the other axioms and postulates. So let's look at an alternate way of looking at it. It's also called the equivalent version of Euclid's 5th postulate. An alternate version to this postulate was given by a Scottish mathematician, John Playfair, in 1729. His version, known as the Playfair axiom, states that for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. Another way of stating this postulate is 2 distinct intersecting lines cannot be parallel to the same line. To understand this axiom, we can take help of an example. Let's take a pair of intersecting lines L1 and L2. Here, each line will have their respective parallel lines. Let's say a line M is parallel to line L1. Now, line M cannot be parallel to line L2 because if we extend L2 and M, they will intersect. Therefore, 2 intersecting lines cannot be parallel to the same line. Hence, we see that the equivalent version of the 5th postulate is true. So in this lesson, we studied the Euclid's 5th postulate and its alternate version. With this lesson, we established that we know what axioms, definitions, and postulates are with respect to geometry. In the next lesson, we will take a look at a theorem and try to prove it using an axiom.